Good afternoon, and welcome to a webinar on environmental monitoring hosted by EAS Consulting Group and presented by Dr. Kathy Knudsen, EAS Independent Consultant. EAS specializes in FDA regulatory matters with a prime focus of assisting domestic and foreign food, pharmaceutical, dietary supplement, medical device, cosmetic, tobacco firms comply with applicable laws and regulations. EAS also works with GMPs for the cannabis industry. EAS is staffed with former FDA compliance and inspection officials and industry executives and is assisted by an extensive network of consultants with many years of FDA and industry experience. Today's presenter is Dr. Kathy Knudsen. Dr. Knudsen works nationwide with food manufacturers on recall investigations, problem solving, training, FDA compliance. With 35 plus years in microbiology and 15 years of full-time teaching, Dr. Knudsen has taught and consulted with companies on laboratory methods, interpretation of lab results, quality assurance, sanitation, environmental monitoring, SOPs, GMPs, HACCP, and FDA's FSMA. Dr. Knudsen also trains in the prevention of intentional adulteration, an important topic on the horizon for the food industry. As a reminder, during today's webinar, you may ask any questions by typing them into the questions box. And with that, I will say thank you for joining EAS, and I'll turn the presentation over to Dr. Knudsen.
Thank you. I am happy to be with all of you. The experience I draw upon today comes from training laboratory technicians to swab as a full-time instructor here in Green Bay at our technical college, from working with facilities on testing through contract laboratories, delivering industry workshops, and most importantly, being boots on the ground and conducting root cause investigations for pathogens in facilities where either the quality team has identified the need for a consultant to assist them or the company has announced a recall and must do a root cause analysis for the source of contamination. In the past year, I've been in 2 large companies assisting with a risk assessment project with no identified need. They were not in crisis, just the need to understand the processing environment. Kudos to those companies for digging deep into the conditions of the environment. Here is the outline of my talk today. I will discuss routine environmental monitoring for Salmonella and Listeria, FDA Swab-a-thons, FDA for a day, risk assessment or root cause investigation. Why do you want to conduct a risk assessment? Who will be involved in a risk assessment, what supplies are needed, what tests will be run, how the results will be compiled and used, when will the risk assessment be executed, where will samples be taken, and how will the project be funded. There's an important concept to keep in mind, and that is if the pathogen is present, you want to find it. Finding the pathogen is hard, and you dig deep and take hundreds of samples. So what do the following look like? We'll first look at routine environmental monitoring. There we have the concept of seek and destroy. And so going along with my previous comment, you do want to find the pathogen, and then it's all about risk assessment and what you're going to do about it in follow-up, and then FDA Swab-a-thons, and then risk assessment in general. So during one investigation, I found Listeria in the screw hole of a homemade cutting board. The cutting board had 2 pieces that were mounted onto the back of it with screws, and we removed the 2 pieces, swabbed between the 2 surfaces that were sandwiched together with a sponge, and then got into the screw holes with a swab. It is bittersweet to find a pathogen. As a microbiologist, I get really geeked out and excited because I have beaten the odds and actually found the pathogen. But that particular finding was followed by the sobering realization that I had found Listeria essentially on a food contact surface that was associated with all of the facility's product. So I am very fully aware of the consequences for industry in doing this work. So first of all, with salmonella, we think of salmonella as hiding in dry processing environments, wherever there's manufacture of low water activity ingredients or products, and it is present in bird droppings. Water is the enemy in these environments, and within these facilities. Without water, salmonella may be hiding in a niche and not move, but once water is introduced in any way, the salmonella can pop to life, multiply, and move in rivers throughout the facility, starting from the roof all the way down. Also in drips and with aerosols that we create in the food manufacturing facility. Control of water in a dry operation is absolutely critical. For routine environmental monitoring of a dry operation, you look for exposed product in processing and packaging. Salmonella can fall in or be sucked into the product. Although traditional microbiology does identify Salmonella as the target pathogen in a dry operation, I have heard that the FDA is also swabbing for Listeria when they go into those operations, and I have heard that many times that the FDA is doing that. I heard last week that if you are swabbing for Salmonella, you should be thinking about Listeria and perhaps swabbing for Listeria as well. And if you are swabbing for Listeria, you may want to consider pathogenic E. coli and whether that is a risk in your facility, and you may want to be swabbing for that as well. With FDA, there is no guidance document for Salmonella in the way that there is one for Listeria. And so here with routine environmental monitoring of Listeria, we have the FDA guidance document. Listeria is associated with operations that are wet, cleaned. It is ubiquitous, so it can be potentially found on any surface. Because Listeria grows in refrigeration, cold operations are vulnerable. In January of 2017 is when we got this FDA document, Control of Listeria Monocytogenes in Ready-to-Eat Foods, Guidance for Industry, Draft Guidance. So FDA final guidance and FDA draft guidance documents are FDA's current thinking on a topic. In this case, my recommendation is to follow the Listeria draft guidance as if it is a rule. That is not true for all guidance documents, but in this case, that is my recommendation. If your company chooses not to follow part of the guidance, and there are companies that choose not to, what you need to do is be prepared to justify the reasons why you are not. FDA would say that if a company can prove that their environmental monitoring program meets the rigor of the guidance, the procedures may be acceptable. Do not wait for the final guidance to be published. Go ahead and follow this guidance. As you think through your product being defined, do you have a ready-to-eat product? And if you do, I challenge you to validate any post-packaging treatment of the product, because then you are not expected to have a Listeria environmental program. I'll share two examples with you. Both of these examples I have learned from my workshop participants who have been with me to become PCQIs. The first was a pickle manufacturer that sealed pickles in poly bags. NC State published validation of pickle treatment post-packaging if the correct procedures and parameters are followed for time, pH, and concentration. And that means that they would theoretically not have to do a Listeria environmental monitoring program. And the second example is with a hot fill soup. After sealing, this actually was a fresh soup. After sealing, the time and temperature were validated to kill Listeria. They had to do Listeria environmental monitoring for their SQF certification, but were able to decrease the frequency and number of tests because of not having to do it for FDA. If you are like me and you want to see this in writing, there's a hyperlink there to the draft guidance document, and the information that I just went through is on page 1. Next, FDA Swab-a-thons. First, I apologize to the FDA for the term swab-a-thon. I know you don't like it, but it works so well. It has a great concept. So within this concept of FDA coming in and doing a large number of swabs, there are different situations. For example, FDA assignments. In the past couple of years, I've seen the following two. One was for dietary supplements, just on the edge of food processing, and that was for salmonella. The FDA had chosen the top 10 dietary supplement manufacturers, and they were going in with no warning and doing a swab-a-thon, and that was for the purpose of gaining data from that industry. The same was true for the raw milk cheese factories. There was an FDA assignment there to collect data, basically. Then there are the preventive controls investigation. I have more information for you coming up on the comparison of a GMP investigation versus a PC investigation, and swabbing may be part of a PC investigation. And then for cause investigations typically are for root cause investigation after a recall announcement, and are again without warning, so a company does not know that the FDA is coming. The next line is the FDA's Investigations Operations Manual, the IOM, and you can find more detailed information there of what the investigators, what the inspectors are trained to do. So for example, just to give you a little snippet of information, there is in that manual for salmonella, collect at least 100 swabs, ideally 300 or more. The majority of those swabs are going to come from zone 2 and less from zone 3. In general, FDA takes very few, if none, from zone 4. And then under Listeria, collect at least 50, ideally 100 or more. For Listeria, the emphasis is going to be zone 1 and zone 2. And then there is a statement in that manual that if you are doing side-by-side samples of those swabs yourself, sending those in for testing, the FDA does request that you share the results. So you need to be aware of that. What does FDA recommend to inspectors for swabbing? In addition to this resource, and let me tell you, the page numbers. This was page 85 and 86 of chapter 4. And then the Listeria guidance document that previously we had a hyperlink for. There is 2 pages in there that you can review, and that is page 34 and 35. So the big question is, what companies will FDA go to and swab? So I want to share a little bit of information here with you. FDA does not share its inspection priorities. If you ask them what the priorities are for who they intend to go to and swab, they will say to do research on past recalls and to keep up with current recalls and warning letters. So when we look at the list here, we have the for cause investigations that I just reviewed, and that typically is after a recall. And then if you manufacture a ready-to-eat product, you are high on the list. And if your product supports the growth of Listeria, you are even higher on that list of ready-to-eat product facilities. So beyond that, the next bullet, if your product is known to be of high risk because of past recalls, because of warning letters, because of competitors, if you have had a recall in the past years, you can expect to see FDA back again. And then If you have any facilities that are associated with you, if you're part of a large corporation, multi-facilities, those other facilities will probably see the FDA as well. And then keeping up with the recalls of your competitors, past and any current investigations, and also for the warning letters. And you can sign up on FDA website to receive notices of those. So I heard a fantastic analogy last week. I was at the Wisconsin Laboratory Association, and I'm going to steal this from Laura Traus of the Department of Agriculture, Trade, and Consumer Protection in Wisconsin. After a plane crash, what does the NTSB and every aviation instructor do? They investigate. They learn the conditions of the crash and discover the root cause. The food industry needs to have the same mentality. When one of us crashes, we all need to learn and make sure it does not happen in our facility. We need to learn from each other. If you are flying the same model of equipment as your sister facilities are, or your competitors are, your company is at risk and can expect an FDA swab-a-thon if that other facility has a recall. If a facility within your organization has a recall, you want to make sure that you're partnering with them and going throughout your whole organization, making sure everybody's good. So what to expect in an inspection? And this is getting to the information on the GMPs and the preventive control inspections. So as a lead instructor of PCQIs, the preventive controls for human food, I am on a quarterly webinar where we are presented with information. And so some of this information comes from that webinar, and some of the information comes from the annual meeting that was held in July. In Chicago this year. So the fiscal year 2017 started in 2016. So in 2016, under FSMA, the largest businesses were under compliance, that is having 500 or more employees. FDA had a fiscal year 2017 goal of 300 preventive control inspections, of which either 165 or 163 were accomplished. My notes were not clear. I apologize for that. And that was going back to the webinar in February that we had. Of that 300, 240 were slotted for domestic and 60 were slotted for foreign. And you can see that 117 and 46 were accomplished. And in the same year, the same fiscal year, there were 720 GMP inspections. So we know that when FDA is coming in, when the inspectors are coming in, and if your state is contracted with FDA, the greatest chance is that it's going to be a GMP inspection. But now ramping up with FSMA, there's going to be more and more PC. And we were told in February that it was averaging 60 to 67 hours. In July, when we were given updated information about the current fiscal year that we're in, we're almost at the end. So fiscal year for FDA starts October 1st. They were doing their calculation of inspection time a little bit differently because they had to account for teams going out into the field. So first of all, for FDA, the scope of the work carried over from 2017 to 2018, and that is that they were going to inspect the large companies and now the small ones, which came under compliance in 2017, a year ago. So the goal was 500. And again, this is data that actually was current as of the beginning of June, presented to us in July. So 500 for domestic and 100 for foreign was the goal, 210 accomplished and 101 accomplished at that time. So they've met their goal for the foreign inspections, and we'll see what it shakes out to be by the end of this month. And then a huge jump in GMP inspections, 3,531 reported as of June, but remember fiscal year starts October 1. And then this is just going back to some more information about how much time are they going to be in your facility. So back in February, it was reported that the GMP inspection was 21 hours. PC inspection was 53 hours, but then, and this is the topic of our conversation today, if they were doing a so-called swab-a-thon, we're looking at a minimum of 68 hours in your facility. And then in June, they calculated that and reported that to us in days. And so a PC inspection is 4 to 5 days, and a GMP inspection, which really surprised me, is 3 days. So they're in your facility for a long time. When I first learned about this topic, first started, I guess, to really focus on this topic, a risk assessment project to make sure that you know what's going on in your facility was back in 2016. There was a program called FDA for a Day, and it was sponsored by the service industries to the food industry. And it was a really great concept. It was a really great program. It has since ceased, so it's no longer available. But a food facility could get 100 swabs, typically the sponge on the stick kind of swabs from the manufacturer. They would have those tested by a company, so the testing was provided. They didn't have to pay for them. And they also received 1 hour of attorney consult time as part of this FDA for a Day program. So it was a really neat concept to get industry talking about the fact that if FDA is coming into your facility and doing this, you really should be doing it as well. And so the other reason why you want to do this risk assessment, what I'm calling a risk assessment project, is because you have two choices. Either do the risk assessment project, or if you have a recall, you will be forced to do a root cause investigation, which is going to be much, much more expensive than doing a upfront project and getting a real good hold on what's going on in your environment. So the goal in environmental monitoring, your routine environmental monitoring, is seek and destroy. That is, if the pathogen is there, you want to find it, and your corrective action will prevent the contamination from reoccurring. The goal of a recall investigation, if that happens, is to shut down your facility, dig deep to find potential sources of product contamination. The swabbing teams need complete and free access to all parts of all equipment. The goal in a risk assessment project, which is what I'm here to convince you of, is to dig deep as if you have found a pathogen in the product. Depending on the facility and how your teams divide and conquer, I suggest a minimum of 3 days, and that's what we were looking at with FDA being in your facility for a GMP inspection. When I do a recall investigation, there are hundreds of swabs that are taken. It can be a matter of weeks before we get done with that recall investigation. Good chunk of the time also is spent in talking to your operation, at least for my teams, talking to your operations people and talking to your sanitation people so that you know what's going on. So the next one is, why do you want to conduct a risk assessment? We have the extent of the risk assessment will depend on your environmental monitoring program. If you have a robust environmental monitoring program, you may not have a great need for a risk assessment project. So for example, I was in a produce processing facility for a risk assessment project, and they were already doing 200 swabs per week. That is intense. And so they had a huge amount of data, and we were able to focus our project and get deep into the equipment with a fresh pair of eyes coming in. No matter what the size of the risk assessment project and how many swabs you will test, you will learn the sanitary condition of the equipment, the sanitary condition of the environment. You will learn operational procedures from your employees, and you may have some surprises there. Identify improvement opportunities, and with a plant shutdown, which is what I'm going to suggest and recommend, you will build in a clean break in the event in the future that you may have a recall. I work with a potato salad manufacturer where the salads are made in huge bowls, and after every single batch, that bowl is cleaned and sanitized. So that is the clean break for that step. It is easy to see clean breaks at the steps leading up to mixing. The tricky part is going forward into packaging and with the sharing of equipment. And I know a lot of you have that consideration where you're looking at that final packaging step, especially if you're in a dry operation. Wet operations are easier for identification of a clean break because we frequently clean and sanitize in wet operations. When I'm in a dry operation and the question is asked about when was the whole plant shut down for that clean break, the answer is often never. And I truly sympathize with that. So the bottom line as we go into our next slide is, are you willing to devote more resources to a risk assessment project, as does DNA to a recall investigation? So now we're looking at who will be involved, and I've got 2 slides on this for you. The asterisk is my identification of members of the swabbing team from experience. And so you should have someone from quality assurance or whatever you call that quality assurance department. You may or may not have lab techs. It depends on the skill level and if they are suitable and available to do swabbing. Sanitation doesn't necessarily have to be involved, as does pre-op, in physical swabbing, but you definitely want to talk to those people and find out they're a wealth of knowledge, and so we talk to them a lot. And in pre-op, I'm thinking of weigh up, I'm thinking of warehousing. There's all kinds of things that are before operations. So then you do want to have someone on the swabbing team from operations, both processing and packaging, because they know the equipment, they know the flow of traffic through that area. Maintenance, you absolutely are going to need. If you can get 2 maintenance people per team, that's even better. If you have engineering, consult with them on their expertise. And a little bit about a consultant before we go to the next part of the list. When you hire a project consultant, you are getting a fresh pair of eyes in your facility and someone who may be familiar with the same equipment that you have from their previous work in other manufacturing areas. And therefore, someone who may already know the likely sources of microbial niches and be able to advise you on how to open up that equipment and get to them. Consultants are hired to swab facilities because we are really good at it. As I said, when I go into an investigation, I do hundreds of swabs, and I've done that over and over and over again. With 2 teams, I'm typically in a situation where I'm in a 2-team project. We can take up to 150 swabs a day. We advise on the testing as well. When the lab starts getting data back to you and talking about presumptive and confirmation and serology, we can help to interpret those results and continue to advise you on testing. We ask maintenance to open up equipment and tear down pieces of equipment with little or no pushback from maintenance and from operations, because I know that a lot of you out there have that comment from your people of, we've never opened that up before, we've never done this before, we could break the equipment, and sometimes it's easier to have the consultant in saying, we have to open this up. If the orders have come down from the top to do whatever the consultant asks you to do, we will be your new best friend and we will be able to get that done on your behalf. We can get even the most stubborn employee to come around to our thinking and to understand why we are there and what the goals of the project are. So in addition, you will have some involvement at some level from your QA manager, director, VP. I've been on a project where the VP of quality assurance was right there with us side by side doing the investigation. And of course in ops, so you have manager, director, vice president there. You will be talking with your contract testing lab because they're the ones going to be doing the pathogen work and probably some other testing for you. You may want to involve your attorney as you get results and you need to be making decisions about what to do with those results. And then you have your carrier for shipping and getting the samples off to, getting hundreds of samples off to the lab on a daily basis. You do want to think about every step along the way, from ordering supplies for the risk assessment project all the way to shipping those samples, and conduct training with your people ahead of time as much as possible so that everybody's on the same page. So we're thinking about labeling, taking and handling the swabs and sponge samples, who is going to receive the results of this project, who will receive but who will be the person who will receive and compile the results, because then you have to get your team together and analyze the data. And then there'll be your action plan that is created and who will have charge of that. And then you'll have the individual steps and the responsibilities going out to your people. So what kind of supplies are you going to need to do this kind of project? I've got a list here. I'll just read real quickly through them. We have swabs. You may want both dry and pre-moistened. We have the sponge on a stick, which I tend to use a lot of those. Those are sterile and pre-moistened. Extra DE neutralizing buffer is for samples where you know that there is sanitizer present, perhaps floor samples from traffic patterns, and you want to boost up the neutralizing buffer a little bit. Your shippers, your frozen ice packs, alcohol wipes and alcohol spray and paper towels, gloves to change as needed, either in between samples or as appropriate, and an extension pole to reach is really great. And of course the ladder as well. You're going to need that to go up there. So back in the 90s, I was training college students to sample food contact surfaces and non-food contact surfaces. And at that point, we mostly were using the swabs. And now as I go into facilities, I mostly use the sponge on a stick style, but we still do need the Q-tip style swabs to get into microbial niches, to get into small spaces. The example that I gave you of the screw holes on the cutting board is true for every screw that's taken out, every bolt that's taken out from a piece of equipment. You want to get into those sandwich areas. Nozzles, for example, are into other areas where you're still going to need that swab. Make sure that you're ordering enough supplies. I said 150 swabs per day, and then however many days you can do the investigation. My rule, not really my rule of thumb, but I would be really happy to see you get 600 to 800 samples. With 600 to 800 samples, you're going to get a really good picture of the facility and you're going to get really good data from that. So what kind of data are you going to get? What tests are you going to run? This, of course, has to be figured out ahead of time. Sometimes we're choosing testing as consultants on the fly because we see conditions where certain tests are going to give us great data. And with pathogens, you're going to contract first. Let me start with this. You're going to contact your contract laboratory to discuss the volume of swabs that they're going to be receiving, but you can also confer with them on the type of testing that you're going to be doing, making sure that they have enough supplies on hand as well, because they're going to get a dump of a large number of samples. You should be concerned about pathogen testing on food contact surfaces and surfaces that are associated with food contact surfaces. So when we look at that first bullet of pathogens, thinking about Salmonella, thinking about Listeria, you want to be very, very careful about that. And that's why I have the second bullet, which is indicator tests. And then that leads also into the quantitative tests in the third bullet, which are indicator tests. So up above in the pathogen list, I have do not test for Listeria monocytogenes. So you, in the case of testing for Listeria from a food contact surface, you can have your lab just stop at Listeria and not confirm all the way out to Listeria monocytogenes for a project like this. Now, of course, the FDA has the thought that if the Listeria test is positive, they want you to take action as if it is Listeria monocytogenes. And that would be from a food contact surface. And your corrective action will follow up appropriately on that, depending on what surface it is. So then there are two indicator pathogen tests that I use. One is HTUB, and the hyperlinks are there, and that one is for Salmonella, so it's a Salmonella indicator test, and the next one is for Listeria, HQA, that is a Listeria indicator test. The other indicators which come out as numbers for you are aerobic plate count, Enterobacteriaceae count, and yeast and mold count, if that's appropriate for your product. If yeast and mold is not anything that you're concerned about, you don't need to do that one. And so we typically are running aerobic plate count and Enterobacteriaceae to look at those numbers, and then when we do data analysis, we do some groupings of how many are at a very low count versus how many are at a very high count, and does that make sense for the site for which those samples were taken. So this is going into who will be copied on the results. You want to control the data, and having the project data sent to the most appropriate people is what you want. And then who at your facility is going to be responsible for compiling all the data, getting that in a form that the team can look at for analysis. You may want to get a map of your facility for the environmental samples and mark the positives there so that you start to see a picture of where those are located. You should be doing that in your routine environmental monitoring program, just to stick that in, but definitely have the hits on a separate map for the project, so that you're aware of that. And any types of calculations you do, or counting of certain, positives versus negatives, that kind of thing, all needs to be done by someone. What this is going to do then is it's going to carry over into your environmental monitoring program and help you develop a more robust environmental monitoring program. You will talk through, and as much as ahead of time as possible, figure out what the corrective action is going to be and how you're going to implement that, and assign that to people and put that on your action plan for the project. And then any positives that you get, you should go back and vector and re-swab to confirm the absence of the pathogen after you've taken corrective action. So I find in my work that there are two kinds of companies. Either you are not used to finding the pathogen, and so a project like this is going to dig deeper into the environment of the processing and packaging steps and into your equipment, And when you find it in the project, remember that it's a good thing. And so from the project, there will either be a greater frequency compared to your environment, compared to the routine environmental monitoring, or there will be a huge increase. And that is what really blows companies away. When they do a risk assessment project like this and they start to find the pathogen in places where they haven't looked before and come to the realization that it's much worse than they thought it was. And so whatever camp you fall into, either your environmental monitoring program is very robust and you have a good handle on what's going on, or you're in the other camp where you need to really ramp it up and you need to get this under control. Both of those are very beneficial for industry. So when are you going to do this? And what I'm really talking about is, when are you going to shut down? When are you going to shut down and do a environmental monitoring risk assessment project? What are some of the situations that can push you to do this? In my ideal world that I live in, that would be scheduled annually. And if you can do a risk assessment project along with your preventive maintenance schedule on equipment, that would be great. That would be the ideal world. What I want you to think about is any type of situation in or around your facility that involves construction, because construction is a red flag that you will potentially develop problems in the product. That has included road construction outside of buildings in the area of which your building is located. It has included construction external to your walls of your building. It includes construction within your building, and that I would include within that the installation of equipment. Any moving of equipment, installation of equipment, internal construction, anything new that's going on there, it's a big red flag that maybe something has gotten stirred up, maybe something has been contaminated, and a lot of times in our investigations, we can trace back to these events. Then if we're kind of shifting to that annual basis, do you have a slow season? Even if you don't have a super slow season, you probably have a season right before you have a big push, a big high season. For some companies, that's a week after Christmas, or maybe the week after New Year's, when they can take a breath and say that that's over. And then for the last bullet, for other companies, you want to do this project after you have seen more positives from your routine environmental monitoring program, and then you bring in more boots on the ground, whether that's from other facilities or you bring in a consultant, but you address it. You definitely take notice and address it. And then where do you get the samples? We have Zone 3. Remember that FDA typically doesn't do Zone 4, but there may be a good reason for you to do that. And when you're looking at Zone 3, I want you to think about the traffic patterns. So I've talked about getting that blueprint for marking any positives, but also what I do is I get a hold of a blueprint and I do talks with the operations personnel and anybody else who's traveling through the facility to find out what the traffic patterns are. I observe the forklifts, hand carts, and carts, for example, maintenance carts, and just find out where they are as well. My comment here on the list for truck means company vehicle. Do you have a company vehicle that is going from your facility to another facility, or maybe to a wastewater treatment facility or something else where there's a potential cross? And drains. Drains can be both Zone 1 or Zone 2. And so we don't want to forget about them. What I want you to think about when you're thinking about zone 1 and potentially zone 2 is anything that's homemade, any place where there are pieces of equipment that come together. I mentioned unscrewing, taking bolts out, any place that there's a gasket. Old equipment, of course, whenever you get the comment, well, we've never taken that apart. Any part of your equipment that is difficult to reach during cleaning. And if your sanitation people are not giving you good answers on what that is, or if a certain part of the equipment is reached in the cleaning, then open it up and find out what's in there. Any place where there is water in a dry operation. I am a human drip detector. I can walk through a facility and see drips coming down from pipes, not just condensation, but I'm talking about leaky pipes. It's amazing. Once I was in a dry operation they were manufacturing a powder, and it was their bagging room, and I noticed a slow drip from an overhead pipe, and I pointed it out. One of the challenges when I'm in a facility is anything that I point out, I always like to see whether the company is repairing it right away, or at least by the next day when I come in if it's been repaired, and that's an indication of your food safety culture. So in this particular case, it was still dripping the next day, and I took a closer look and I noticed that the floor was actually pitted from the constant drip, constant slow drip. So that pipe had been dripping so long that the drip had corroded the floor. This is an example of poor food safety culture. You don't want your people walking through your facility day after day after day, seeing things and then not seeing them anymore, and they don't get fixed. And FDA will see those things as well. Ooh, this is the big question. How is this project going to be funded? It is going to cost a lot of money, and I'm not going to mince any words about that. If your team takes 800 samples and tests for Listeria at $20 per test, which would be a relatively reasonable price, that's $16,000 just for Listeria testing. That does not include the cost of the other things listed here, your supplies, both disposable and non-disposable. You're going to go through a lot of gloves. The additional tests that you're going to do, if you're doing the aerobic play count, the enterobacteriaceae count, your equipment downtime, of course, your team project time, of course, and then all of the expenses in corrective action, which need to be done. There may be some capital expense. You may have to get better monitoring equipment. There's all kinds of small things that add up. And then if you do involve a consultant, or if you do involve your attorney, that's going to be more money. So in summary, I hope that I have convinced you to conduct a risk assessment project. When you do this, you'll be very happy. Once you get over the cost and the sticker shock, you'll be very happy. And so we have build your current routine environmental monitoring program. You will know the sanitary condition of the equipment. You will know the sanitary condition of your processing and packaging environment, and perhaps beyond. You will know what your employees are doing for operational procedures, anything that has changed, anything they're doing on the side that you didn't know about. You will identify improvement opportunities, and you will build in a clean break into your system. So with that, just a couple more comments. Don't wait for the FDA to inspect your facility to tear apart your equipment and take hundreds of swabs. Knowing the microbial condition of your equipment and facility, you can take corrective actions for any issues that you find, and always be ready for an FDA inspection.
Great, thanks. We have a couple questions from the audience. The first one is regarding the cost, and one of our viewers is wondering about the possibility of compositing samples so that they're bundled together.
Yes, that's an excellent question. So there's a difference between routine environmental monitoring, compositing of samples. And so in the Listeria guidance document, the FDA recommends that no more than 5 samples are composited. And for a risk assessment project, most of the time, we do not want to composite because most of the time that sample is very specific to a piece of equipment. So if you were doing Listeria testing, not Listeria monocytogenes for a risk assessment project, and you had a piece of equipment that was large, and I'll just use the typical example of a conveyor belt. Perhaps you want to do a larger area than what you normally do in routine environmental monitoring, and so that would be appropriate to composite samples. The other thing that happens in the project is I will get a sample. Perhaps first I will sample with a sponge and get the general area. But if it's a very small niche where I need to get in with a swab, I will take multiple swabs and I will keep breaking off those swabs into the bag with the sponge. And so the lab may receive a single bag that has a sponge, maybe 2 sponges, and 3 or 4 different swab heads. And that's appropriate because it's from a very, very specific location. And so when you get those results back, you know what that location is. You don't want to composite samples that if it gets a positive result, you then have to go back and do all those swabs. You really want to do a deep dive and get that information right away.
The next question is, how do you account for building size when you're considering how many swabs you should take?
That's a very good question. So again, the first part of the answer is that there's a very big difference between a routine environmental program and the size of the facility versus the size of the facility when you're doing your project. So with a very large facility, you obviously will have more swabs because you have so many different rooms perhaps that you need to go into. What I would do is get together with your team and based on results from your routine environmental program, focus in on what the highest risks are. And those highest risks will typically be packaging, because that's where your product is exposed, and any post heat steps. So it'll help you narrow down as far as where the highest risk is, and then that is where you want to do where you want to shut down that equipment, and where you want to do your zone 1, very, very focused on those pieces of equipment that are post kill step. So post pasteurization, post cooking, post baking, post roasting. Then branching out from there is going to be more of the zone 3. And with zone 3, what I would focus on is your traffic patterns. And so is there a possibility that from those other areas of the facility, there could be the potential movement of a pathogen, cross-contamination from a zone 3 into those post-kill step areas?
All right, we've got time for just one additional question, and someone in the audience wants to know your thoughts on whole genome sequencing for positive results.
Yes, it is a huge growing area. So we are all just grabbing onto the roller coaster and trying to ride it and enjoy the ride as much as possible. So long-term thinking in the future, whole genome sequencing is here to stay, and we all have to deal with it. And I do think that there are times when whole genome sequencing is good information as far as investigations go, in that you can really find out if you've got different samples coming up as positive, and especially over time with your environmental monitoring program, you do want to know if these are new strains that have been introduced into the environment, or are these all the same strains? And whole genome sequencing will tell you that information. And so there's the transient strain of a pathogen in a facility versus the house pet type that has been there and keeps reoccurring and coming up no matter what you do. And so, yes, whole genome sequencing is very good in investigation, as appropriate, very, very judiciously, and very, very limited and as appropriate.